Alright, so it says at the top that you are to use the electronegativity value for each atom, and I believe you have a chart like that, a periodic table that has the electronegativity values in the table. You are determine what type of bond is there between these two atoms. And you're also to draw the direction in which the electron is being pulled. The electron will be pulled in the direction of the greatest electronegativity. Yesterday we went through the periodic table and we determined that which atom has the most electronegativity. Fluorine. So fluorine does. So fluorine has a value of 4.0, so in most situations the electron is going to be pulled toward the fluorine atom. So you'll notice here that it also says that the values for electronegativity can vary from textbook to textbook. And I'm just using the values here of 0.04 to represent a covalent bond that's nonpolar. It means that there's neither atom is stronger than the other to have a stronger direction of pull. They're sort of equal. Then 0.5 to 1.4, the bond is said to be covalent, but it's polar, which means there's going to be two poles to it, a positive end and a negative end. And then the ionic, we're going to use the value 1.5 and greater than that. Some textbooks use 2.0, some use 1.8. So depending on the textbook that you use, you could just, put the type of bond there is. And sometimes they're like 1.5, 1.4, and so you say, well, it's kind of in between. Usually you can just pick one or the other and you'll be okay with it. Alright, so let's look at the first one. You have arsenic and sulfur, and they're going to bond together. So we're going to try to determine what that bond is. So if you look at the electronegativity value for arsenic, the value is 2.2. Sulfur, the electronegativity is 2.6. So the delta En, which means the difference in electronegativity, is said to be 0.4. So what type of bond do we have here? Not only covalent, but nonpolar. So in this particular problem, you don't have to really draw a direction of pull because the pull is equal. Let's go to the second one. We have cobalt and bromine. Cobalt's electronegativity is said to be 1.9. Bromine's electronegativity is said to be 2.9. So the difference between the two is 1.0. Hence, it's said to be a polar covalent bond. So which atom is going to want the electron more often? The bromine. So in doing the direction of pull, let's use the symbols of the atom. So we'll put CO and Br, and we'll draw a line to demonstrate the bond. The direction of pull, we said, is to bromine, and so the cobalt will have sort of a delta positive demonstrated at that part of the bond. This is pretty easy, isn't it? Okay. Let's. I think you should be able to do most of the other ones yourself, but let's go down to where we have nitrogen, which is right here. So nitrogen, its electronegativity value, I believe, is 3.0. So if it's bonding to another nitrogen, what will that be? 3.0. The difference between them is, so here we definitely have a nonpolar covalent. There's no polarity to that bond at all. So what does that mean? It means the electron is shared equally by each nitrogen. This is showing you that up here that bromine is more dominant in holding on to the electron as opposed to cobalt. Here, since the value is 0.0, the nitrogens will share that electron equally, so there's no polarity to that bond. Does that make sense? Okay, so let's see if you can do most of the other ones yourself. If if you have any questions, just feel